Have you ever noticed that the upper portion of a bicycle's wheel moves faster than the lower portion? Today in this video, I'll explain why this happens and the role of friction in a wheel's motion. So let's begin. Before you move into our main discussion, let's be familiar with rolling motion and friction. When all the points of an object move toward the same direction, the motion is translational. All the points of this wheel moving toward right, and therefore the motion is translational. When a point moves in a circular path around a fixed axis, the motion is rotational. Here, all the points of the wheel are moving around the center of the wheel. So this is a rotational motion. Static friction is the force that resists the initiation of motion between two surfaces at rest relative to each other. More to add, this is a self-adjusting force, which means the increase in applied force increases the static friction. When two surfaces are in motion with respect to each other, or one surface slides with respect to the other one, the friction is called sliding friction or kinetic friction. When you apply a torque in a wheel, the wheel rotates, and since the wheel is touching the ground, it is not sliding either. We can say that the wheel is at rest relative to the ground. Hey, do you want to say that the wheel stopped? But we can see the wheel moving forward. Well, since the bottom of the wheel is touching the ground and it is not sliding, therefore the bottom of the wheel must be at rest with respect to the ground. In other words, we can say that here two planes are at rest with respect to each other, and that's why static friction comes into play. The ground applies a reactive force to the wheel that keeps the wheel moving forward, and this reactive force is the static friction. And since the bottom of the wheel is at rest, the translational velocity and rotational velocity both are equal. If you focus on a specific axis of the wheel and draw the vector sum of translational and rotational vectors at each point, you will notice that the length of the vectors in the top are bigger than the vectors in the middle, and the length of the vectors in the middle are bigger than the vectors at the bottom. The length of this blue vector is the largest because here the translational vector and rotational vector meet each other at 0 degree. From this, we can clearly say that the length of the vectors increases from bottom to the top. The motion of the wheel is like this. Imagine this is an axis of the wheel, and from the vector analysis, we have shown that the vectors at the top are greater than the vectors at the bottom. That's why the upper portion moves faster and the lower portion doesn't move as fast as the upper portion. And that's why the spokes that are at the top, they become blurry, and the spokes that are at the bottom, they don't become blurry, they become visible.